Okay, section 2.3 is called Nuclear Structure and Isotopes. So in the last section we were talking about how the structure of the atom was determined, and so now we're going to talk about the accepted atomic structure. So this is the one that's good for now, okay? So I mentioned this the last time. You have the nucleus, which is shown down here, okay? And the nucleus is made up of protons and neutrons. The protons have a positive charge, which are the red dots down here. And the neutrons are shown by blue and have no charge, so they're neutral. Okay. So the proton has a mass 1,800 times that of the electron. And the neutrons have basically no charge, but almost the same mass as the proton. The atomic number, which is symbolized by the symbol Z, is simply the number of protons in the nucleus. It's a characteristic of that element. So all elements have the same number of protons and have the same atomic number, which is what this just says. All the atoms have the same atomic number, which means they have the same number of protons. And then you have a mass number, which the mass number symbolized by A is the total number of both protons and neutrons. So we basically don't count electrons because they weigh so little. So the atomic mass, or the mass number, is simply you add up the protons plus the neutrons. A nuclide has a definite number of atomic number, so it has a definite number of protons, and a definite mass number, so it has a definite number of neutrons. So carbon has two different nuclides. It has carbon 12, okay? So this is the atomic symbol, and this is the mass number, okay? And sometimes you'll see a 6 written here, but that's kind of repetitive because all carbons have 6 protons. So we don't really need to have, let's see if I can draw it here, a 6 right there, but sometimes you will see it that way, okay? Carbon tells me it has 6, okay? So you see that this is carbon 12, this is carbon 13. Both of them have 6 protons because in order to be carbon, it has to have 6 protons. But this one has 6 neutrons because if I take the 12 minus the 6, it is equal to 6, versus this one is the 13, the mass number, minus the 6 to equal 7. And so that's right there. Okay? So the number of neutrons is gotten from the mass number minus the atomic number. All right? And so this is showing the symbol here. Actually, I don't like this one because of the fact that it has the mass number at the bottom. Okay? But these are the two nuclides of carbon. One with 6 protons and 6 neutrons is the carbon 12. The carbon 13 has 6 protons and 7 neutrons. Alright, and so nuclei, some atoms that have, or elements that have more than one nuclei, but these all mean the same number, atomic number, so elements, different mass numbers, are called isotopes. Hydrogen has 3 isotopes. Hydrogen 1, or hydrogen, has 1 proton, and the mass number is 1, so it has 0 neutrons. So this one has 0 neutrons. Alright, so it just has a 1 proton. Deuterium is the hydrogen 2, okay? So it's still, because it's hydrogen, has 1 proton, but it also has 1 neutron. I should say the fact that this is 1 proton. 1 proton. Alright, and I have tritium, okay, which is 3, it has a mass number of 3, so it has 2 neutrons and still with 1 proton. And so all 3 of these have 1 proton because of the fact that they're all hydrogen. Okay, they have different mass numbers here, here, and here because they all have different number of neutrons. So this is basically the figure here. This one has no neutrons, this one has 1, and this one has 2. If you're doing research and they talk about working with heavy water, that's water that the hydrogens on the water have been replaced with deuterium. And so you can actually do studies based on the mass because of the fact that it has more neutrons. It's a heavier atom than that of hydrogen. Okay, so problem number 44 in the book says it gives me the number of protons and neutrons of various atoms and asks which atom is the isotope of atom A. So what am I going to look at? Am I going to look at the protons or neutrons for the isotope? Okay, well, the protons do what? They give the identity of the atom. So therefore, I'm looking for the same one that's the same as 32. And that's atom D. So the answer to the first one here, if I put numbers here, this is 1, this is 2, and this is 3. 1, I'm going to write over here, 1 is D, okay? Which atom has the same mass number as atom A? So I'm going to make a new column called the mass number. So by adding up the protons and the neutrons, I get 71. 33 plus 38 also gives me 71. 38 plus 50 gives me 88. And 32 plus 38 gives me 70. So the answer to number 2 is B. It shows A and B there. And question number 3 is the identity of all the atoms. So what am I going to look at? Am I going to look at the protons, neutrons, or the mass number to get the identity? I'm going to look at the protons. Okay, so on the periodic table, I'm looking for element number 32, or element 33, or element 38. So here are the atomic symbols. Element 32 is germanium, arsenic, strontium, and back to germanium. Okay. Number 46 says nitrogen has a mixture of nitrogen 14 and nitrogen 15. So it wants the protons, neutrons, and electrons of the neutral atom, meaning neutral means that the number of protons and the number of electrons are equal. So this means protons equals electrons. I started to write neutrons. Okay, so the protons equal the electrons. And so here's my table. Okay, so nitrogen 14 has how many protons? Well, all nitrogens have 7 protons because it's element number 7 on the periodic table. Neutrons, I'm going to take the 14 minus the 7 to get 7. And because of the fact that it's neutral, these two have to equal. So it's also 7. Okay? So for nitrogen 15, because it's still nitrogen, it has 7. But now I take the 15, it's probably going to put it right there, but is 8. And again, because if it's neutral, the electrons have to equal the protons, so it's back to 7. And that is the end of the video for section 2.3.